Hello everyone, my name is Kelly Robbins. I'm an assistant professor in the section of plant breeding and genetics at Cornell University. And today I'm going to be presenting some of the work that we've been doing in the breeding informatics area of inquiry as part of the Innovation Lab for Crop Improvement. Before I get started, I would like to take a moment to thank the organizers of NAPB 2021 as well as Stephen Kresovich for giving me the opportunity to present here today. To start, I'd like to thank the amazing team of people that I get to work with on a daily basis. Within the breeding informatics team, we have Mallet, who is a postdoc in the Robbins lab, a quantitative geneticist who does a lot of work on this project focusing on breeding scheme optimization. Francisco and Sam are both amazing developers that are working on putting together a lot of the enabling capabilities that we're delivering as part of the breeding informatics area of inquiry. We also have several collaborators outside of the project. We work closely with Excellence in Breeding, the BRAPI project, as well as the Integrative Breeding Platform to deploy BMS to our partners. Here we have a diagram that I pulled off of the ILSI webpage, just to give an idea of where the breeding informatics area of inquiry fits within the broader landscape of the Innovation Lab for Crop Improvement. So with breeding informatics, we're really primarily tasked with building the types of enabling capabilities that enable effective deployment and routine adoption of the tools, technologies, and the methods that are being developed by the priority setting, trait discovery, genomics, and phenomics areas of inquiry. Our primary focus in the breeding informatics area of inquiry is to work with our partners to drive them towards a data-driven breeding approach. This means implementing capabilities to generate accurate predictions of performance for advancement and recycling decisions early in the breeding pipeline, as early as possible. We also work with our partners to do simulations to identify ways to leverage the tools, technologies, and methodologies and capacities that are being developed as part of the ILSI project to optimize their breeding pipelines and maximize performance in terms of varieties being delivered to farmers that meet their needs. To do this, we're focusing really on three core areas: data digitization, analytics, and the implementation of continual improvement processes. While there are many definitions and formal implementations of continual improvement processes, within the breeding informatics area of inquiry, our focus is really just on the core idea of continual improvement, which is the incremental improvement of a process over time. In many ways, plant breeding represents a continual improvement process where we're trying to make incremental increases in genetic gain over time. So why the focus on continual improvement? Well, one, because making a series of very large and disruptive changes to a breeding program decreases probability of successful implementation. You can also put a very heavy strain on programs with limited or restricted capacity to be able to make those types of changes simultaneously. The second is that research and innovation are not static. We're constantly developing new technologies, new methods, and new tools, which in turn will affect our breeding strategy as we try and determine how to leverage new tools and technologies to maximize the efficiency of a breeding program. Also, changes in environmental conditions, changes in market conditions can lead to different breeding objectives, different breeding focuses, which in turn are going to impact what types of enabling capabilities need to be in place for a breeding program. And this really represents an iterative cycle that needs to be repeated consistently year over year within a breeding program. And so within the breeding informatics AOI, what we want to do is be able to provide a lot of the software and analytical infrastructure to enable programs to collect the types of information, to have the systems in place to be able to implement and effectively implement a continuous or continual improvement process within their breeding program. The starting point for any engagement with a breeding program is to first really understand what their current breeding strategy is and what their current breeding processes are. Now, this can be a fairly time-consuming effort. It involves a lot of back and forth between ILSI and breeders within the breeding programs that we're working with. But the idea here is to try and document with as much detail as possible exactly how varieties are developed, how they're tested, how breeding objectives are being defined, what the focuses of a breeding program are. This gives us a nice baseline to really understand what the current state is, because that's really critical. If we're going to implement improvement of a breeding strategy or improvement of a breeding process, we first have to understand what the current process is. And for this, we are leveraging really some excellent tools that were developed by the Excellence in Breeding platform. In particular, we use the Excellence in Breeding Pipeline Manager to work with breeding programs to identify really in detail what the different steps of a program are. Once we have a clear understanding of what the current state of a breeding program is, what the current approaches and strategies are, we then work with the program to start to develop simulation code to be able to develop really an in silico version of the breeding program. And to do this, we leverage the AlphaSim R code, and we work with breeders to identify various scenarios. We conduct analysis on historical data to estimate parameters, and then we can work and go iteratively back and forth where we look at a scenario, we test it, we can compare it to the current state. We have an iterative back and forth with the breeders to identify ways in which we might want to tweak a scenario. Once we identify different approaches to optimizing a program that seem to have high impact, we can then move more onto a consulting phase of the interaction and breeding strategy, where we're going to work with our partners in the breeding program to develop proof of concepts, to try and validate some of the findings, and also provide recommendations to the programs on how they might go about implementing some of these changes in their breeding program, and how we might be able to track and monitor the impact of these changes within a program. One of the common scenarios that breeding programs are interested in is the implementation of genomic selection. And while in theory genomic selection is often a far superior approach to traditional breeding methodologies, it's also very complicated to implement at scale in an effective way. And oftentimes programs don't necessarily have a good idea of where a good starting point is for the implementation of genomic selection. In the breeding informatics area of inquiry, what we recommend is to take a phased approach to the implementation of genomic selection. In the first phase, which we call informatics, we're really focused on implementing a lot of the foundational capabilities that you need to have in place to be able to effectively utilize genomic selection. This is things like informatics, genotyping platforms, imputation platforms, standard operating procedures. We recommend implementing genetic quality control and pedigree verification as a first step. And then starting to do routine genotyping of all material that goes into the pipeline. A key element of genomic selection is this ability to constantly refresh your training set by routinely genotyping everything that goes into a yield trial. We also work with programs to look at what are some cost-effective experimental designs that can enable them to start routinely genotyping. Once these foundational capabilities are in place, we recommend moving on to optimization of the actual variety testing or variety development pipeline. This would be things like reducing time to multi-environmental trials, reducing the number of years tested, recycling earlier within the VDP. Once that's really in place and programs are very comfortable with the idea of genomic selection and they've validated the value of implementing genomic selection within their program, we start to work with programs to move towards rapid cycling approaches, which in theory are the best, but often in practice, some of the most difficult approaches to work with. When it comes to the programs that we're working with within the Innovation Lab for Crop Improvement, many of these programs really are in phase one, which is getting in place the types of foundational capabilities you need to implement genomic selection. And that's really oftentimes our initial focus in our engagement with our partners. Our efforts to deploy enabling or foundational capabilities and technology really starts with us having a discussion with the ELC partners to identify what are really the key use cases and gaps that are in place right now that need to be addressed in order to move towards more of a data-driven approach to breeding. Once we've had those conversations, we move towards deployment of appropriate software systems. From there, we identify functionality gaps in the deployed software systems, and finally, our developers work across multiple projects and with our partners to write the types of software that's needed to bridge these gaps and extend functionality. Within the breeding informatics area of inquiry, we really don't have the capacity to build the types of large software systems that need to be at the core of any modern breeding program. Thankfully, many of these systems have already been developed, and so a lot of our initial focus is just working with the program to identify what the right existing software solutions are. And so here on this slide, I have some examples of some of the major software systems that are out there and that are in common use within public sector breeding programs. And we can generally sort of divide these up into systems that support core breeding. This would be BMS, developed by IVP, BreedBase, which is developed out of the Boyce-Thompson Institute, and the enterprise breeding system that's being developed by the CGIR. In the genomics area, there are two major open source software systems that are being widely adopted. One is the GOBI project and the GOBI Genomic Data Management System, and GIGWA. Finally, field data collection is a really important aspect of data digitization. We want to be able to have data flowing right from collection all the way through to final results of analysis without having a lot of manual steps, because that introduces or has the potential to introduce errors and also makes things much more complicated for the breeders. And so on the field data collection side, we work very closely with PhenoApps. And the effort in PhenoApps is really being led by the phenomics area of inquiry within ILSI. It should be noted that not all of these systems can be so cleanly defined into these broad categories. For instance, BreedBase does have genomic capabilities. Enterprise breeding system, when complete, will be deployed with the GOBI system on the back end handling the genomic needs. Where we come in with the breeding informatics area of inquiry is the fact that for a lot of the types of use cases that these programs need support for, really none of these systems individually can fully support. And so there has to be a lot of work to really develop the piping between systems to be able to fully support a workflow from start to finish. Genomic selection being a prime example of this. You need genomic data, you need phenotypic data, as well as the analytics to be able to effectively implement genomic selection. And while this has been widely recognized as a really critical gap in terms of what's available out there in software for breeding programs, it's been traditionally very difficult to address, because these projects, the way in which they're organized, often makes it difficult to really develop the kind of software that bridges these gaps between systems. And so this is a gap that we recognize when developing the project, and we're fully committed to being really focused on this aspect of providing software solutions and new tools and methodologies to our partners within the ILSI project. Within the ILSI project, we try and be agnostic in terms of what types of software we work with our partners to deploy and adopt. That said, we do have some criteria that determines whether or not we're willing to work with a certain software project or a certain piece of breeding software. First, the software needs to be well supported, it needs to be well documented, and there need to be some accessible resources for training and adoption. The second is the software needs to either be BROPI compliant or committed to working with us to implement BROPI. For those that are not familiar with BROPI, BROPI stands for the Breeding Application Programming Interface. BROPI has defined a standardized set of data model structures that communicate the basic information of plant breeding. It's a technical specification which software developers can turn into code which communicates using the standard. And the advantage of having these standards in place is that when we're trying to build functionality that connects across multiple pieces of software, multiple software systems, is we can build it once, and then it is easily adaptable to different types of configurations of software that any given program might be deploying within their breeding program. Currently, BROPI provides specifications for core breeding, for germplasm, for phenotyping, and for genotyping. These represent the types of capabilities that you need to be able to support a large number of breeding use cases. But there are still some gaps, both in the phenomic space as well as the analytics space. And so within ILSI, we're actively working with the BROPI project to implement standards in some of these additional domains to fully support the types of workflows and the types of use cases that we're trying to support as part of the ILSI project. In terms of closing the gaps, what we really want to implement, as mentioned earlier, is a fully digitized system in which, from the point of collection in the field all the way through to results that can be used to make decisions, either advancement, recycling, decisions about potential changes to breeding processes, is completely digital and completely supports the types of work processes and breeding processes that are being implemented within a breeding program. We start by deploying existing systems. In this example, we're looking at PhenoApps, BMS, and Gobi, but we could easily replace these particular software systems with other BRAPI compliant software, and this type of workflow would work the same. Any breeding program that has deployed these systems will quickly realize that there are lots of gaps that are present in terms of being able to fully support modern breeding processes from end to end, from collection all the way to decision support. And so the software developers within ILSI are primarily focused on identifying these gaps, utilizing BRAPI to be able to map across systems, and then to build the type of code to fill in these gaps and really provide the types of end-to-end support you need to fully optimize a breeding program and to effectively implement continual improvement processes. So what are we doing? So we're working on building systems that connect between the various pieces of software. PhenoApps is being deployed as part of ILSI. It falls under the phenomics area of inquiry, but there's a long history of PhenoApps working with a lot of these software systems and working with the BRAPI community to implement these types of connections. That's not necessarily the case for other pieces of software. For instance, BMS is a great piece of breeding software, but does not provide the types of adequate support needed for any type of genomic-enabled breeding process. Gobi, on the other hand, is a fantastic software system for managing genomic information, for implementing genomic-specific breeding processes, but does not really have the capabilities to manage core breeding processes. And so one effort that we're really focused on right now is being able to map BRAPI endpoints between the BMS and Gobi system to enable these types of use cases in a breeding program. Another common gap is just being able to run state-of-the-art analytics that are needed to make the best possible breeding decisions. Right now, it oftentimes involves pulling out Excel files, running various types of software. To be able to effectively do this, to some extent, you have to be a biometrician or a quantitative geneticist and have some coding abilities. So we're partnering with the Excellence in Breeding Project to build a proper analytics engine that can work directly with these systems to enable breeders to be able to submit requests for analyses, have those run, and then have those results presented to them in a way that makes it easy or easier to make quality decisions about the breeding program, about advancement decisions, and about recycling. So where are we at currently with the breeding informatics area of inquiry? Well, we have ongoing work with our partner or our Center of Innovation in West Africa to document breeding pipelines and identify simulation scenarios and implement simulation code. We're focusing primarily on this COI on the breeding strategy piece because they are fairly advanced in terms of deployment of breeding software. So they've already deployed BMS to manage their core breeding processes, and they're in the process of deploying GWA to manage their genomic information. For our COIs in West Africa, they're really at the start of the journey in terms of being able to digitize their data. And so we've been working very closely with BMS as a partner. We've deployed the BMS system and we've completed training on the BMS system. As mentioned, we're currently mapping BRAPI endpoints between genomic management systems, both Gobi and GWA. And we have initiated software development to begin to start supporting genomic breeding use cases. Many of these programs aren't routinely using genomic information yet, but it is on the horizon, and we want to make sure that these capabilities are in place when they start doing routine genotyping. And finally, significant progress has been made in the development of germplasm evaluation tools, and this is being done in collaboration with the Excellence in Breeding. We hope to see the first release of this piece of software towards the end of the summer, early fall, and we'll be continuing to enhance those capabilities moving forward. And with that, I would just like to thank everyone again for being here. And thanks again for the opportunity to speak. I look forward to the interactive Q&A session to be able to address any questions you may have.